Hello everyone, the topic that we are going to discuss today is encoders. So we will be seeing what is an encoder. We will start with 4 by 1 encoder, we will extend it to 8 by 1 encoder in such a way that we should be able to develop any given encoder. Then we will look at the applications of encoder. So first, what is an encoder? Okay, it is a combinational circuit that converts binary information which is in the form of 2 power inputs to n outputs. In simple words, we are converting an information which has 2 power n inputs into n outputs. Okay, what do we mean by that? Suppose if n is 2, then 2 power 2 we are converting to 2, n value is 2, or next slide, if n is 3, then 2 power 3 we are converting to 3, means 8 lines we are converting it into 3 lines. So we can have such encoders. We will start with 4 by 2 encoder. So as the name suggests, it has 4 inputs and 2 outputs. Construction of the table is very simple. Now this is useful for such a case where suppose you have different sensor data, okay, and suppose when you have 1 in one sensor and remaining all you have zeros, or let us say a case where you have a ball and then 4 boxes, 1 ball 4 boxes. The ball, if it is in box 1, it is not in remaining boxes, okay, right. So here if suppose you have a ball in this box, then remaining places it is 0, or if we have a ball here, then it is not in remaining places. In such a case, here the possible sequence that we can have is this. Now if you see here, the amount of information here is actually very less, only few number of ones we have along the diagonal. So 4 bit of information is too much for that. So it can be reduced to 2 bits of information, and that is what we do in encoding, we compress the given data. So a simple case of compression we can see here, 1000 can be encoded as 00, 0100 can be encoded as 01, then 0010 can be encoded as 10, then 0001 can be encoded as 11. So as the 1 moves along the diagonal in the downward direction, then this is the same binary sequence, 4-bit binary sequence. I hope everyone knows 00, 01, 10, 11. So this is the simple truth table of an encoder. Now general process what we do, from the functionality we get the truth table we have discussed. From the truth table we will get the Boolean expressions or the logical expressions. From the logical expressions we will get the circuit diagram. So this mechanism is only valid for encoders, it is not valid for other cases. That is, check A1, okay, in this case check A1, where all A1 has 1s, these 2 places. Fine. Now what you do, now where you have 1, you have a 1 at y1, then you have a 1 at y0, okay. So in such a case our expression for A1, okay, in such a case our expression for A1 can be given in such a form. It can be expressed as these situations that are mentioned here. Next, what else we can have, like in this case A1, okay, 2 values, so 2 expressions. Then likewise for A0, A0 if you see where all you have 1s, you have a 1 here and then you have another 1 here. So this is another expression for the A0 that we can have. So here somebody can take this as y0, y1, y2, y3, or somebody can take this as, like in this case, y3, y2, y1, y0. Both are valid. Different textbooks, they consider it differently. Now, if you take y0, y1, y2, y3, let us see what is the expression that we have for a1. Okay. So, a1 here, if you look, you have a 1 here. So, a1 will be y2. Then, where is the other one? The other one for a1 is, okay, if we see y0, y1, y2, y3. If you look at the sequence, we can have the sequence like this: y0, y1, y2, y3, or y3, y2, y1, y0. In such a case, the a1 could be simply y2 and one more here 1 y3. Then what about a0? A0 we have a 1 here, we have a 1 here. So let us see that once again. We have a 1 here, we have a 1 here. So go here, you have a 1. So here what was the sequence that we considered? y0, y1, y2, y3. Okay. So y1, a0, y1, then where else we have 1? We have 1 here. So y3. Fine. So that is how we can get the expressions for a0 and a1. Now, if suppose somebody consider the sequence as y3, y2, y1, y0, then correspondingly these expressions will change and both are valid. Okay. So now we will discuss how to get the circuit from the given equations. So here you can see y3 plus y2. So what you can do, plus stands for OR gate. One OR gate, input is y3, y2, then you have output a1. Then next again plus is OR gate. So input should be y3, y1, plus for OR gate. So this OR gate is for plus and the output is a0. Output is a0. So easily we can construct the circuit diagram from the given expression. Now similarly what you can have is, you can come up with a similar process. Now here a1, okay, where a1 has 1, okay, a1 has 1 at this place. Then where else a1 has 1, okay, here a1, right. So here we are seeing a0. So a0 has a 1 here. Then a0 has another 1 here in this place. Next a0 has another 1 here in this place. Then if you see one more 1 here in this place. So in alternate positions you will have the expression for a0, okay, and that is the reason the expression for a0 in this case is simply y5, y7, y5, y3, y1. Okay, let me explain that once again. Just see where all a0 has 1, here, 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 here. Now see in this path where you encounter 1, you encounter a 1 here. So consider this. Next in this path, see where you have, okay, you have a 1 here. So consider this. Then in this case, let us see, here we have a 1. So consider this. Now again in this case, we have a 1 here in this place. So consider this. Now sum up all these. That will be the expression for a0. So a0 is y7, y5, y3, y1. Now again this order will change. If suppose somebody takes y0 here, y7 here, then correspondingly this is going to change and both are accepted. So in this manner, the same logic that we have considered for a 4 to 2 encoder, we can also use for a 8 to 3 encoder. Now let us look at the applications. So primarily it is useful for compressing data. Here 4 bits of input expression is converted into 2 bits of output expression. And if you see here, 8 bits of input is converted, 8 bits of input is converted to 3 bits of output. And so primarily it is useful for data compression. Suppose there is a video, somebody would like to compress that video, or image, compress that image so that the size of storage or transmission reduces. So it is useful in audio and video processing. Okay, fine. Then it is also useful in, say, natural language processing, machine learning related applications, neural networks, okay, recommendation systems. Suppose you have purchased a product, based on that something else is recommended. Then it is also useful in auto encoders in unsupervised learning, primarily for the dimensionality reduction. So wherever compression is required, there you have the applications of encoder. So that's all for today's lecture. We have seen what is encoder, 4:1 encoder, 8:1 encoder. We have seen applications. Thank you.